afternoon, friends. Today we'll understand the concept of rigid body, which is very important in the relative velocity or finding out the accelerations in the mechanism. So, what is a rigid body? A rigid body is something that absorbs, absorb, absorbs forces, shocks, and everything without changing the without changing dimensions. So let us say that the dimensions are, this is L, H, and this is B. This will remain constant throughout the operation if this is assumed to be the rigid body. Now that also means that there will be no extension of the link or extension of this rigid body, or there won't be any compression of this rigid body. No extensions, no compressions possible. If this is the case, and considering just 2 points at the end of the link, this is the point A at one end, point B at the other end, what will be the relative velocity? What will be the relative velocity of point B with respect to A, or relative velocity of point A with respect to B? What will be the direction of these velocities? Since we have said that this body will not change its dimension, the distance AB has to be fixed. It cannot change. It cannot change on the application of any forces or movements. Now, the object can have rotational plus translational motion. This is your rotational motion and this is your translation motion, right? This link can also have this rotation plus translation, but since we said that this AB has to be fixed, that means the relative movement of this point B with respect to A cannot be translating in this direction or in this direction, right? So there is no possibility of translational motion if we are considering the motion of this point B with respect to point A. There exists only the rotational motion. That means this point B will always be rotating with respect to this point A. Now, if this point B is rotating with respect to point A, we know that the direction of velocity has to be perpendicular or tangential to this rotational circle, right? That means VB upon VB with respect to A will be either in this direction or in this direction, but it can never be in this or in this direction. This is very important concept. Now let us just use it in this pair of links. Let us just use it in the pair of links. Let us say that we have a fixed link A and the other link AB, such that they are connected using a rotating pair. Now if it's connected using the rotating pair, they will only be able to rotate either in this clockwise direction or counterclockwise direction with respect to this point A. That simply means that if we need to calculate the trajectory of this point B, it will be always a circle, which will be given by this, right? Hence, the direction of velocity of B with respect to A will be either in this direction if the link AB is rotating clockwise direction with respect to A, or it will be in this direction if the link is rotating in counterclockwise direction with respect to point A. Here observe that the point A is the center, and the magnitude of the velocity of this point with respect to A is given by VBA is equal to omega into AB. where omega is the angular velocity of this link 2 with respect to fixed link at the point A. Similarly, if there are links A, B and C, we have the link AB, let us name it as a link 1 AB, and we have the link BC, which can be named as link 2. Now they are joined together using this rotating pair. Now point B is common onto the link 1 as well as onto the link 2. By the rigid body concept, we have seen that the point C can only have the rotational motion with respect to point B. Similarly, the point A can only have the rotational motion with respect to point B because they are the points on the link 1. And here BC are on the point on the link 2. Now if we know the angular velocity of this link BC to be omega BC, the velocity of C is with respect to B is given by omega BC into BC, and the direction will either be in this direction or in this direction based on the direction of angular velocity. If the angular velocity is in clockwise direction, this will be the velocity of B with respect to C. If it is moving in a counterclockwise direction, then velocity of B with respect to C is given by this. Similarly, for the link AB, the velocity of A will be perpendicular onto the link AB such that velocity of AB is given by omega AB into AB, where omega AB is the angular velocity of link AB. And the direction of velocity of AB is given by the direction of angular velocity of AB. Now let us just have a simple case over here in which we have the system of links. This is a slider crank chain in which you have a link 1, it is your point A, this is your point B, and this is your point C. This is the crank which is link 2, and this is the slider, this is the connecting rod which is link 3, and we have the slider which is the link 4. Notice that point A is common between link 1 and link 2, whereas the point B is common between link 2 and 3. Similarly, point C is common between link 3 and link 4. If we assume that this slider crank chain is rotating in this clockwise direction, okay, with omega is equal to omega AB, then the velocity of point B with respect to A, which is onto link 2, is given by omega AB into AB, whereas the direction of the velocity of A with respect to B is given by drawing this perpendicular onto the link AB, that is perpendicular on link AB, and it is denoted by the initial fixed point A, right, and the final point B. This is the exact representation. This is A and this is B. This represents velocity of B with respect to A. Of course, it will have this link AB is having the same magnitude as we have obtained in VBA. Now we also know that this is link 3 or connecting rod BC. We know that since B and C are onto the same link, the velocity of point C with respect to B will be perpendicular onto this link BC. Therefore, if I draw a perpendicular like this from the point B, of course we are observing it from the point B, that's why I'm drawing the perpendicular from the point B. So the direction of the velocity of B or velocity of C with respect to B will be either in this direction or in this direction, right? We exactly do not know that what is the resultant direction, since the connecting rod is rotating as well as translating. We do not know the resultant direction, which is in upward or downward, so we do not have to worry about that. Just draw a line. Now, since our A is a fixed point and we know that the slider, this is the slider which is link 4, it is sliding along the horizontal direction because the motion in the other direction is restricted by this fixed frame. Hence, from the fixed frame it will only have the velocity which is in horizontal direction. So this is your velocity of C with respect to fixed frame A, and this is your velocity of C with respect to what? Link, with respect to, not link actually, point B on link 3, right? Now, so point C is on this line as well as on this line. That means there is only possibility that this point C lies on the intersection of these two lines. This direction will represent velocity of C with respect to A, whereas this direction will represent velocity of C with respect to B. And if I invert the direction over here, I can write that this is velocity of B with respect to C. So by this I take a leave. This is just a concept about the rigid body, in which we have seen how to calculate the velocities, relative velocities in a slider crank chain. In the later videos we'll also see how to calculate or how to obtain the velocities of different links. Okay, one point is there that this just does not represents the direction of velocity of B with respect to A, but it also represents the dimensions or so magnitude of VBA is given by AB, and magnitude of velocity of C with respect to A is given by the length AC, whereas the magnitude of velocity of B with respect to C or velocity of C with respect to B is given by CB. So just calculate the magnitude and that will be the velocities. So if it is asked that what is the absolute velocity of C with respect to A, this will be it will be AC, and it will be given by the magnitude AC. Similarly, if it is asked what is the magnitude of or what is the velocity of C with respect to B, this CB represents the magnitude of C with respect to